Hi, welcome back. So today we're going to start off a completely new build. Here I'm showing a few pictures of the old version of the surface grinder, and it was, I would say, very ambitious of me to try that type of model to work, that type of frame, because it was a bit too weak, a bit too large, and sort of all over the place. So here I'm just showing the movement of the table when I, first did the test fit, and here you can see the next iteration of the frame. So I changed almost everything, and here are a few pictures of the almost built up frame. I'm gonna have a separate video on that as well. And because I decided to build a completely new frame for the surface grinder, I then had this frame left over. So I decided to rework the old surface grinder frame into a new small CNC mill frame. And here you're seeing a few pictures of it. And the idea of it was that there's a company called what was the company called? I'm gonna add the note later on here, but they have what's called an inline CNC mill, and it's very similar to the shape of my mill. And the idea of it is that they have a line of these, and they have a very long x-axis, and the parts basically move back and forth between the different mill heads, and they sort of create very complex parts. Because they can it's technically like a 4-axis, very long CNC manufacturing line, and they can do all kinds of different parts and all that kind of stuff. Anyways, here you can see that I'm welding the upright posts up, and on the lower right hand side you can see the what was the old saddle is now going to be the place where the linear rails for the x-axis are going to be basically mounted on. And the saddle is made from 15 times 185 millimeter plate, and the two bars are 20 by 20 millimeter steel bars, all welded up. It's a very strong strong design, and even after milling it, it didn't move at all. Okay, so the the purpose of this mill is to have I would say a relatively low, working envelope, but it would be quite fast. And since I'm having to use it on what I would almost say constant production parts. Most of the parts are going to be very small, and I may need to create a few thousand of them at a time. And on the x-axis, the y-axis work holding table is going to be roughly 400 times 250 millimeters, and that will actually hold close to almost 100 parts. So the mill is meant for very small parts. That's the basic idea. Now, you can see that this video doesn't show me adding in a few other parts. You'll see that in the next video. But the basic idea is that the x-axis are going to sit on 6 posts, and it's going to be, the whole frame is going to be welded, and then it's going to be remachined, because I'm assuming that everything is going to be pulled out of alignment quite fast. And going back to the beginning, the inline mill that I saw, it was very well sort of designed and built. So I decided to try to create something similar, because I didn't want to throw the frame away, because it is a very nice and a very heavy frame as well. And it seems to be very, very strong, because when we did tests, two people standing in the middle didn't really bend it at all. You know, you couldn't really see the deflection on the indicator. So it seems to be, I would say, very strong, very stable, and that's why I decided to reuse it basically. Now, the other clip is going to start in a second, and the idea is that I will have a working envelope of basically, let me think, the x-axis was going to be almost 300 millimeters, the z-axis is going to be 165 millimeters, and the y-axis is going to be 220 millimeters, I believe, something around that. And the basic idea is that I will have, I would say, tooling plates or tooling jigs that I set up, and with that I can basically, and I will of course have to have, you know, reamed holes, pins, so that if I drop a new tooling plate in, I just need to load in the blanks, and then I can set the program to run, and it will run the entire cycle. Well, technically not unattended, but by itself. And initially, the machine will not have the capability of changing tools, but I am in the process of designing a automatic tool changing spindle, which I have already designed one which uses ISO 20 taper tool holders, but the problem with that is it sort of seems too large for my mill, because the largest tools that I have are probably going to be 6 millimeter. Most of the stuff is going to be between 4, let's say 3 and 4 millimeters. And so one of the options is to try to implement something that is similar to the Tormac tooling system, where they have an R8 collet, and basically they have straight shank tools. Or the other option is to basically try to go down to ISO 10 spindle, because as I said before, the collet system is going to be ER11, and I mean technically I could go up to ER16, but again it's the case that a lot of the parts are going to be very small, and I don't really foresee doing almost any steel work, any, you know, hard materials. Mostly it's going to be plastics, and even more than that, it's going to be aluminum. Now, the aluminum end mills, in my experience, you know, you need high RPM, and you need a relatively you need a good controller and such to make sure that you don't break end mills all the time. But I will say that most likely the RPM will stay within the spindle RPM, or spindle motor, is going to be staying in the probably 6,000 to 8,000 range, because I'm planning on having quite a heavy reduction on the stepper motors. The stepper motors are going to be NEMA 23s, and the ball screws are going to be 12 millimeter ball screws with a 4 millimeter pitch. So it's going to be, I would say, relatively conservative on the speed. So I'm hoping that my rapids will be around 1,500 millimeters a minute, and my working speed will be between let's say up to 750 millimeters a minute with a 5 millimeter end mill. Sorry, a 6 millimeter end mill. It seems that I can sort of get away with 500 millimeters on a 5 millimeter end mill. And I'm trying to get a 3-to-1 reduction ratio on my stepper motors to make sure that I have enough torque, but also that I have enough control, enough accuracy in the system, because it seems that the stepper motors really are the biggest issue in at least in my design, because I can't afford, at least yet, I can't afford any servo motors. But if ever the day comes where I want to upgrade, I always have the opportunity to go to either because the frame size, the motor, stepper motor or servo motor's frame size is the same, NEMA 23. I have the opportunity to either go up to hybrid closed loop stepper motors, or even better, servo motors, because I've seen some videos on the Clearpath servo motors, and it seems to be very, very, very good, because the motors start at around $300, and you get a very good system for that. But right now I'm starting with some El Cheapo steppers and seeing how the whole thing basically goes. Okay, so here you can see the underneath of the frame, and I'm almost done with the video as well. And here you can see the sort of finished product, which is half finished, and you can see that I added 2 pieces in the middle. That's where the y-axis rails are going to sit. So this is the side view. So anyways, thank you very much for watching the video. I hope you enjoyed it. I will try to get the next stage of the machine build done within maybe a few months, hopefully, because I'm currently finishing the surface grinder, and then I'm finishing the CNC lathe, because then I can already start working with those. So yeah, anyways, thanks again for watching. Please leave a comment, or you know, like the video if you liked it, dislike it if you disliked it, and let me know what you think. And I'm always open to suggestions on how to do stuff better. So if you have any suggestions, just let me know, and I will be sure to consider them. So thanks again, and have a nice weekend. Thanks.